get 1.483 times 10 to the fifth pascals, or newtons per meter squared. I'll let you guys go back and do that. What I really wanted to do is illustrate the problem set up here, and I'm going to do a bunch more of them. But take a look at what's going on here. Okay? First of all, what do we know about the velocity of the water here versus here, just knowing about the continuity equation?
It'll be faster.
It'll be faster because the area is smaller. What's the pressure here? P1. 1.48 times 10 to the fifth newtons per meter squared, or pascals. What's the pressure here? 1.3 times 10 to the fifth. This pressure is higher here with lower velocity, and here I have lower pressure and higher velocity. Does that seem weird to you?
Makes a little noise.
Pressure is the pressure on a molecule at that point. Okay? Lower pressure regions, things are moving at higher velocities. Or things that move at higher velocities create lower pressure regions. Classic example is if you look at the tarp on a truck. Okay? If you look at the tarp on a truck, as it moves along, it always has this kind of hump to it, right? Here's a big truck with a tarp on top, and it has a hump to it. Do you agree? As the truck is moving this way, and if it stops, the tarpaulin or the tarp sits flat. Why is it up like that?
It's moving it.
The air across the top of the tarp is moving at high velocity, creating a low pressure zone. So the pressure inside the load is higher than the pressure outside the load, and so it causes the tarp to bow outward like that. Okay. Another example I see all the time, and you'll never think about this the same way. On very windy days, if you're observant, if you're looking at your toilet, the water will be going up and down in the toilet on very windy days. Why is that? Yeah, there's a vent stack that goes from your sewer line to the outside of your house. Why do they do that? So your house doesn't blow up. Okay. There's a vent stack. As the wind goes across the top of the pipe, it creates a low pressure zone. And so you get different air pressure coming down the vent stack, and it causes the water in your toilet to go up and down because of different pressures. Okay. So higher speed areas result in lower pressures. This is how wings, partly how wings on an airplane work. There's two issues. There's angle of attack, and there's Bernoulli's principle that aids in providing lift to a wing. So the wing, and I'm going to draw this very roughly, is, I don't know, roughly like that. So if I think of streamlines that come in like so, and they come around the wing, and they meet back up, okay? You're going to end up with, under Bernoulli's principle, these things have to have, more or less, have conservation of energy density. You're going to end up with a higher speed on the top, because it has to cover a longer distance in the same amount of time. So you have, I'll call this V1, I'll call this V2. So V1 greater than V2, V2. So if I have higher velocity, I have lower pressure than on the bottom. So if the bottom's got higher pressure than the top, which way does the object want to move? Up. so it provides some lift to the wing. All right, let's do some more problems. Looking at